Hello, everyone, and good day to all of you. For today, we are going to have our Module 4, which is entitled The Variety of Carbon Compounds. The most essential learning competency is to explain how the structure of the carbon atoms affect the type of bonds it forms. And the expectations are the following. Number one is to identify the group, period, family, number of proton, electron, and neutron of carbon atom. Number two is to determine the uniqueness of carbon atom. Number three, classify the compounds as an organic or inorganic compound. And number four, differentiate organic from inorganic compound. And this lesson is anchored on a division-made module from SDO Caloocan. But before anything else, let us have or let us refresh our mind from the previous lessons that we have. First in line is that atoms comprise of three subatomic particles, which are the electrons, protons, and neutrons. Electrons are the negatively charged particle, while the protons are the positively charged. When it comes to neutron, no charge will be found. Always remember that atomic number, electron number, and proton number of an element are all equal. For example, we have the element lithium here. If you will look at your periodic table, the atomic number of lithium is 3 because it is the third element in the periodic table. So meaning to say, if the atomic number is 3, the electron and protons of lithium are also 3. When it comes to nitrogen, the atomic number of nitrogen in the periodic table is 7. So it only means that the electrons and protons number of nitrogen are also 7. And last one, if we have magnesium, it is the 12th element in the periodic because the atomic number is 12, and that will determine the proton and electron number of magnesium, which is also equal to 12. So that's the formula. Atomic number is equals to the protons and electrons. So these three are all balanced or equal to one another. Okay? So now let us have a recap on the following things. Observe this figure. By just looking at this diagram, we can be able to detect what is this element. But how? How are you going to determine the element by just looking at this drawing? Simple as this. Just count how many electrons are moving around the nucleus. Take note that only the electrons can orbit and move around the nucleus because the protons and neutrons are located inside the nucleus. So, meaning to say the protons and neutrons are concentrated at the center and they cannot move. The only one that can move are the electrons. So, protons, electrons, and atomic number are all the same. So, meaning to say, if this element has 7 protons, meaning to say the electrons are also 7. So, let us count the electrons. 1, 2, 3, 4, 5, 6, 7. So there you go. We have 7 protons and 7 electrons. And that is also equal to the formula that we have a while ago that electrons and protons are equal. So if this element has 7 electrons, what do you think is this element? You can check the answer in the periodic table. 7 electrons, meaning the atomic number is also 7. 1, 2, 3, 4, 5, 6, 7. So in that case, we have found the element as nitrogen because the electrons present here are 7. It only means that atomic number are also 7 and that element is nitrogen. How about its election configuration? You know how to do that? Yes, because I have shown you the pattern on how you are going to draw the election configuration of the given element, and that is to follow this pattern starting from 1s to followed by 2s2, just follow the arrow, and then 2p6, 3s2, then 3p6 followed by 4s2, and then 3d10 before 4p6, 5s2, and so on and so forth. So you have to look always at this pattern so that you will not be confused. Okay, going back to our element nitrogen, that is 7, so 1 is 2, 2 is 2, and then 2p3. And if you're going to add the exponent 2, 2, and 3, you will get 7. And that is the atomic proton and electron number of the element nitrogen. So for today, I will just give you some clarification on some of the things that I have observed on your module, because some of you get the wrong interpretation on how are you going to draw the atomic orbital, and most importantly the ms, or the fourth quantum number, or simply the spin of the electron. So here, if the nitrogen has 7 electrons, you have to write down first electron down to the 7th electron, and then draw the atomic orbital, which is jive to the spin of the electron. As you remember, the arrow or the box here represent one orbital, and the arrow that I will put inside the box represent one electron. And in the s orbital, there is only one. In the p sublevel, there are 3 orbitals. Okay? And in each orbital, there could be a maximum of two electrons that an orbital can hold. So in P, there will be 6 electrons there. In S, there is only 2 electrons that can occupy the space. So let's have a recap of this nitrogen element about its atomic orbital and its spin. So one arrow up. What is the equivalent spin of the arrow up? That is positive 1/2. And then the second electron are inside the 1s2, and that is arrow down, and that is equivalent to negative 1/2. Then let's proceed to 2s2 now. It's still s, so one orbital only. Arrow up means positive 1/2, followed by arrow down. It means negative 1/2. And let us now have the 2p3 orbital. It is p now, so meaning there are 1, 2, 3 orbitals, because p has 3 orbitals. So according to the Hans rule, we have to fill up all the orbital first by drawing or by making an arrow up before making an arrow down. So arrow up means positive 1/2. And then next is also arrow up, which is positive 1/2 again. And then the last is arrow up, and then the spin is positive 1/2. So this is the thing that I am talking about. Most of you got the wrong interpretation about this. They interpreted it as an alternate arrow up, up, down, and then positive to negative, positive to negative. No, you have to follow the Hans rule by filling up all the orbitals by arrow up before arrow down. So arrow up means positive. So if there's 3 consecutive arrow up here, meaning there will be 3 consecutive positive 1/2 also in the ms, or in the fourth quantum number, which is the spin of the electron. Okay, and there's no more for the arrow down, because we already reached the electron number nitrogen, which is 7. Okay, it's already 7. So let's move on to the next example, which is the, what do you think is this element? Again, how? How are you going to detect what element is this? By just looking at the drawing? Can you tell me how you will be able to know what element is this? Of course, you have to be familiar that atomic, proton, and electron numbers are the same. So here, the yellow and the orange concentrated at the center are the protons and neutrons located in the center, which is the nucleus. And around the nucleus, you can find some orbits where the electrons are located and can move around. So, like what we did in nitrogen, all we have to do is to count this blue circle. And this blue circle is the one, or this blue circle represent the electrons. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. So there are 9 electrons in this diagram. What do you think is that element having 9 electrons? So just follow these 9 electrons, meaning the atomic number is also 9. So you have to look at your periodic table. So count 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we found it. The element here is the fluorine because it has 9 electrons, or the atomic number is 9. And the configuration of fluorine will look like this. So for us to reach 9 electrons, again, we have to follow this pattern, the electron configuration pattern. Okay? So 1s2, 2s2, and 2p. And the exponents are the following. So if you will add 2 to 5, you will get 9 electrons, which are also the electron number of fluorine. So let's do the atomic orbital and the spin of the electron. So like what we did in nitrogen, draw the 1s2 orbital, which is only equal to 1 orbital because it is s. Arrow up, meaning positive 1 half. Then arrow down, that's negative 1 half. Let's proceed to 2s2, 1 orbital again. Arrow up, positive 1 half. Arrow down, negative 1 half. And then in 2p5, since it is p, we have to draw 3 boxes here. And then draw the arrow, which represents the electron. Arrow up, positive 1 up. Arrow up, positive 1 up. Arrow up, positive 1 up. And then, since all the orbitals in the p are filled up, we have to proceed to the arrow down. That means negative 1 up. And then arrow down again, negative 1 half. There you go. So I hope this lesson or this matter is important to is understood by everybody, because in your module there are so many students who get confused about the fourth quantum number, on how to write or when to write the positive and the negative. You have to follow the orbital. If it is going up, positive. If it is going down, negative. And do not alternate the positive and negative. Just follow the arrow up or the spins of the electron. Another thing that I have noticed with wrong interpretation, or everybody got a mistake in this, is the election configuration. I think they did not follow this. Some of you got the wrong answer here because they do not follow this pattern. Before 3D, there should be 4S first. But some of you write 3D first before 4S2. No, it is wrong because in this pattern, after 3P, that's 4S followed by 3D. So, this is the thing that I have noticed on your module. Okay, so I will give an example. Let's have an element zinc with a higher electron number, and that is 30. So you have to make the electron configuration of zinc following the pattern that I have presented. So we got 1s2, 2s2, 2p6, 3s2, 3p6, and after that 4s2 first before 3d10. So is that equal to 30? If it is equal to 30, let's proceed to the next, which is bromine having 35 electrons. So the configuration will look like this: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, then 3d10, and since we need 5 more, so that will be 4p5. Okay? So do not do not answer your module in a faster manner. Just take your time because you have to follow this pattern, okay? And also, please take your module seriously, okay? I hope this part is clear to you. Let us move on to the next lesson, or let us have now our topic for today, okay? So based on the review that I have made, let us see now if you can be able to name the element based on the diagram presented here. Okay, so this is how will answer your activity 1. I have here one element. So again, I have here a picture of the atom. What do you think is this element? So like what we did in the previous slide, all we have to do is to count the number of electrons orbiting around the nucleus, and then you're gonna check it from the periodic table to know what element is that. So from here we have 1, 2, 3, 4, 5 electrons. So if we got 5 electrons, meaning the atomic number is also 5. So 1, 2, 3, 4, 5. There you go. We found the boron as the name of the element in the first picture. And in the boron, you can see that the group number of boron is 3. That's the vertical column. And the period number of boron is 2 because that's the horizontal part of the periodic table. And then when we say family, we will call it the boron group. So what are other symbols that belong to the boron group? You have to look at your periodic table again. So the boron group are the following elements down here. So from boron, aluminum, gallium. Here are the boron group on the group number 3. So boron is located in period 2. So let's see. So we have aluminum, gallium, indium, thallium. So those are the other symbols found on boron group. The second diagram, how can you name this? Again, we have to count the number of electrons. 1, 2, 3, 4, 5, 6, 7. So we have 7 electrons. And looking at the periodic table, it is nitrogen. Nitrogen belongs to group 5 or column 5, and it is located in period 2, and the group is also the family name, which is the nitrogen group. Along with the nitrogen group, we can find the phosphorus, the arsenic, the antimony, the bismuth. So these are the nitrogen group. Nitrogen is positioned in period 2, group 5. Okay, going back. So the nitrogen group are the phosphorus, arsenic, antimony, and bismuth. And the last diagram will also tell us what element is this. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 electrons. What is that? The atomic number is also 9. So checking the periodic table, the ninth element in the periodic is the fluorine. Okay? So fluorine is the name of the element here, and it is located in group 7 and in period 2. The family of fluorine is called the halogen group. And then on the halogen group, check your periodic table. You can find also the chlorine, the bromine, the iodine, the astatine. So they are what we call the halogen group, and they all belong to group 7 because the group is also the family name of that element. Okay? So in module number 4, we have to focus our attention on a special characteristic of the element carbon and how carbon can create different kind of bond and compound with other elements. So what is carbon? Carbon is a chemical element having the symbol letter C and with an atomic number of 6. It came from the Latin word carbo, which means charcoal. It is one kind of nonmetallic element with 4 valence electrons. You know, carbon is all around us. We are using so many things every day that contain the element carbon. Like for instance, the pages of your book and notebook, the ink on its pages, plus the glue attached to it. So, aside from the ink on the wine that sometimes adults drink, there is a carbon there. On the leather shoes that you are wearing, carbon is also present. On the carpet on your floor, carbon will be found. And also with the gasoline that is very important in many ways of transportation now, carbon is also there. Aside from that, on the plastic and all other grocery bag that we are using, carbon is present. On the lead of the pencil, carbon is also there. So there are so many uses of carbon in our everyday living, and that how significant the carbon is in our daily lives. So let us know more about carbon. As I said a while ago, the atomic number of carbon is 6, which means that the electron number is also 6. The proton number is also 6 because atomic, electron, and proton number are all equal to one another. How about its valence? We know that carbon is in group number 4. So meaning the valence is 4. So because we know the valence or because we know how many valence are there in carbon, we can now draw its Lewis symbol. Do you still remember how to draw the Lewis symbol? If you know the valence number of an element, you can be able to draw the Lewis symbol because the valence will determine how many dots are present in the carbon. So if carbon is 4 valence, how many do you think dots will be here? Yes, it will be 4. So 1, 2, 3, 4. So there are 4 dots representing 4 valence. And according to periodic table, carbon is located in period number 2. So carbon is very important in our everyday living. But take note that there are two kinds of compounds that we are going to study in this module. And that is organic and inorganic compounds. So what are the difference between the two compounds? When I say organic compounds, these are the chemical compounds that contain the element carbon. So all compounds that contain carbon is called organic compounds. On the other way around, chemical compounds that do not contain the element carbon is what we call inorganic compounds. So all compounds without carbon is called inorganic. Okay? So that's how organic and inorganic compounds become distinct to one another. So how are you going to answer now your module number 4? Listen carefully because as of this moment, I will give you some examples on how to answer activities on your module number 4. Let's start with activity number 2. On activity number 2, you can find there a table with element, group number, and valence and Lewis. Because these are the things that you are going to supply for you to answer this activity 2. So for example, I have here fluorine as an element. What do you think is the group number of fluorine, valence, and Lewis? What are you going to do to answer this? Of course, your periodic table will help you to answer that. So the fluorine is located in 1, 2, 3, 4, 5, 6, 7, group 7, and in period number 2. Okay? So really the periodic table is a very significant tool in chemistry So looking at your periodic table, the group number of fluorine is 7, which means that the valence are also 7. And for that, we can be able to draw the Lewis symbol of fluorine having 7 dots, because 7 dots is also equal to the valence number. So we have to draw 1, 2, 3, 4, 5, 6, 7 dots. So there you go. This is the Lewis symbol now of fluorine. Next in line, we have aluminum. So what do you think is the group number of aluminum? So, periodic table again. Where is the aluminum here? Okay, down below the boron, it is located or it is belong to the boron group. If the boron is the third group 3, aluminum is also group 3. And also, it is one of the mistake that you got in your module 3. Because when I asked what group number is boron, many of you answer this one, 13. No, you have to write 3. The group number is the 1A, 2A, 3A, 4A, 5A, 6A, 7A, meaning 1A group 1, 2A group 2, 3A group 3, 4A group 4, and so on and so forth. Do not copy the 13, the number above the Roman numeral. It is not the group number, okay? So, correction, the group number of boron, aluminum, gallium is group number 3. Okay? So aluminum belongs to group 3, meaning the valence are 3, and the Lewis symbol are or will look like this. 1, 2, 3 dots. The last example is magnesium. Magnesium is located on group number 2, meaning that the valence number of magnesium are also 2, and this will be the Lewis symbol, 1, 2. I hope this activity number 2 is clear to you. Let's move on to the next activity, which is the activity 3. In this activity, you can find several compounds, and all you have to do is to put them in correct order. Okay, for example, I have here CO2. What compound is this? That is carbon dioxide. Another example is H2O. You are very familiar with this. This is a water. And then we have C6H12O6. We have studied this in our first quarter, and that is glucose. And then HCl refers to hydrogen chloride. And then we have Al2O3, which means sapphire. And the last example is C3H8, meaning propane. So these are the compounds that I will give to you as an example, and then I will show you how to answer this activity 3. All you have to do is to arrange this compound given into the correct label. Are they organic or inorganic compounds? Again, how are you going to know if it is organic and inorganic? And that is through the presence of carbon. If carbon is there, meaning organic. If carbon is not there, meaning inorganic. For example, carbon dioxide. Can you see a carbon here? Obviously, carbon dioxide, meaning there is a carbon. So that is organic compound. How about the next? Glucose, C6H12O6. You can find here the carbon element. So that is organic. And we have the C3H8 or the propane. Carbon is present in this formula, so that is organic. And the remaining compound are all inorganic simply because as you will look at their chemical formula, there are no presence of carbon, H2O, hydrogen and chlorine, aluminum and oxygen. So there is no trace of carbon in the following compounds. So they are classified as inorganic. So the most important thing in this activity is for you to identify what is organic and inorganic, and for you to know that you have to look at their chemical formula, because in that formula you can be able to determine what are the elements present in that compound, like this. Okay, again, if the carbon is present, organic. Without carbon, that is an inorganic. Okay, let's move on to next chapter. Activity 1 and 4, do not discuss activity 1 and 4 because they are very easy to understand. So let's move on to check your understanding part in module number 4. In page number 7 of your module 4, you can find different compounds. And you have to label them again as organic and inorganic. Just put a check on where it applies. But for you to answer this part, you should know the chemical formula of each given compound. Because on your module 4, only the compound name is given, that no chemical formula is present. So you have to look for the chemical formula first. You can check it from the Google or other textbook, or sometimes it is on my slide now. So for example, I will give you, we have vinegar, acetic acid. What is its chemical formula? Because we have to know the formula first so that we can identify if it is organic or inorganic. That is CH3COOH. So there is a presence of carbon, hydrogen, and oxygen here. So obviously there is carbon, meaning vinegar is a organic compound. How about an animal fat called lard? The formula is C21H42O5. Here it is very clear that carbon is present. So meaning to say lard is an example of organic compound. How about iodine? Is that an organic compound? Iodine is one element found on your periodic table. Okay, so what is this? Since there's no trace of carbon, that is classified as inorganic. Hydrogen peroxide. The formula is H2O2. Can you find a carbon here? No. So we have to label it as inorganic. And the last one is naphthalene. That is C10H8. You can see here an element carbon on its formula, meaning to say naphthalene is an example of organic compound. That's how easy you are going to answer your understanding. So you have to look first for the formula so that you can determine if it is organic or inorganic. Okay? So let us continue our study about carbon. And with that, we are going to proceed to module number 5. And the title is Super C You See Everywhere. The most essential learning competency is to explain how the structure of the carbon atoms affect the type of bonds it forms. And the expectations are the following. Determine the uses of organic compounds and cite examples of each organic compound. Number 2, find the properties of common organic compounds through experimentation. And number 3, okay, there's only 2 expectations. Again, in our previous module, we have studied about organic compounds, right? So what are organic compounds again? These are the compounds containing carbon that can be combined with other elements like oxygen, nitrogen, phosphorus, sulfur, and halogens. What are examples of organic compounds? So in this module, I will now give you the examples of organic compounds, uses, and properties in real-life situations. So, some examples of organic compounds that we can use every day are alcohol, acetone, gasoline, naphthalene, acetic acid, vanillin, acetylene, esters, and so many more. These are just few of the examples of organic compounds. These are some things to ponder before we proceed to our module number 5. We have to take note of this following information. First, organic compounds can be produced naturally by plants and animals. So, like for example, carbohydrates are being produced by plants during photosynthesis. So, natural process. The nucleic acid and proteins, these are some examples of organic compounds that are produced naturally. So meaning these are not natural organic compounds. But aside from that, organic compounds can also be produced artificially by man or by human being. Examples are liquefied petroleum gas or LPG, gasoline, lubricating oil, kerosene, and many more. So because of the new trend in technology and because of the intelligence of people, they can produce organic compounds now. These are what we call artificial organic compounds because they are only produced by humankind. Okay? So what are these organic compounds that I am talking about? Let's take a look at the different examples of organic compounds that we can use in our everyday living. Organic compounds are very useful compounds that people can use daily in their everyday living. They plays a significant part on how people will survive in this world and continue living. They can give comfort, convenience, and safety. So let us now know more about organic compounds and their uses. For example, the gasoline. It is very useful in the mode of transportation because gasoline is being used as a fuel for many vehicles and many cars can run through gasoline. So, obviously, gasoline is one significant part of our daily living and that is one example also of organic compound. Aside from that, lubricating oil is used as lubricant. While acetone, are you familiar with that? It is being used as nail polish remover or simply cleaner. The vinegar or the acetic acid, you can use that in cooking and you can use this also as a cleaning agent. So as a cleaner. And then the butane is the fuel that can be found in lighters. So you have to cook every day, right? For you to eat food. And most of us use liquefied petroleum gas or LPG to cook something. And if this tank is empty, we cannot cook. So we need a fuel inside it for this to run and for us to cook. Formaldehyde or formalin is one kind of organic compound that is being used as disinfectant for the bacteria and viruses to go away or simply as preservatives. It is being used to treat human cadavers or the deads, people who are dead. Okay? So, talking about the organic compounds and uses, do you know what does it mean when you say fuel, when you say lubricant, antiseptic, or disinfectant? So, fuel meaning material that is burned to produce heat or power. Like the gasoline, it is being burned to produce power so that some vehicles can run. When I say lubricant, like lubricating oil that is used in some wheels of the cars, it is a substance used to reduce the friction between surfaces in contact like wheels. Antiseptic, it is a substance that stops or slows down the growth of microorganisms. Disinfectant, like alcohol, formaldehyde, it is a chemical liquid or agent that destroys the presence of bacteria. So most of the time we use alcohol now as a disinfectant so that we can destroy the presence of some viruses and bacteria so that we can be safe as always. So that is the definition of what we so-called fuel, lubricant, or sometimes disinfectant or antiseptic. So going back to the things that we have to remember, again, carbon can form four covalent bonds because of its four valence selections. It can form bonds with other elements, and it can also form three kinds of bond. the single bond, the double bond, and the triple bond. Why? Because of the special characteristic of the carbon atom. It can form four covalent bonds because of its four valence electrons represented by dots. Okay? Chemical bonds between carbon and other elements can create several kinds of compound, a lot of compounds. So the bonds can be short, long, straight, or even branch chain structures. And each kind of organic compound has a particular properties. They do not have the same characteristic. So talking about the characteristics of carbon and organic compound, what are the properties that we are going to talk about now? Talk about. That's why carbon become a special compound or element. Let us see now what are the properties of organic compound. So aside from the uses, fuel, disinfectant, antiseptic, organic compounds has also their own properties that make them special, that make them significant and important in our lives in everyday living. Because, as I said a while ago, organic compounds are very significant part in our daily lives. They play a significant role. Okay, so aside from the uses, let us now know more about its properties. So I will now tell you what are the properties, its meaning, and some examples so that you can understand it further. So the properties, what are they? First in line, we have the odor. When you say odor, it is the smell of the compound. When you smell it, you can tell if the element or compound has strong or weak odor. For example, the gasoline has a strong odor, while oil has a weak odor. Aside from odor, we can have also the viscosity as a property of organic compound. What do you mean by that? Viscosity is the measure of liquid's resistance to flow. Okay? Example, oil is more viscous than alcohol. Meaning to say, oil will take time to flow compared to alcohol or other liquid like water. But alcohol, water can flow freely or in a faster rate. Oil will take some time to flow, and that will make oil more viscous compared to other organic compound. Aside from viscosity, we also do have volatility. That is the measure of the tendency of the compound to evaporate or turn into gaseous state. So, example, acetone is more volatile than oil, meaning acetone can evaporate faster than oil. Acetone, in a few seconds, it can turn from liquid to gas state in a faster rate than oil. It will take some time or few hours for the oil to evaporate. So meaning to say acetone is more volatile. And then, so let's have the next property, which is the flammability. What is that? It is the measure of how easily the substance will burn. Example is gasoline is highly flammable material. Next is the phase. Phase is the state of matter. It could be solid, liquid, or gas. Example, alcohol and acetone are in liquid state. And the last property is all about solubility, which refers to the maximum amount of substance that will dissolve in a specified amount of solvent. For example, when you say soluble, it is mixed as one. When you say insoluble, it will be separated into two. Okay, so I hope you will be familiar about the properties of these following organic compounds. But for you to further understand this, later I will show you some video clips on how odor, viscosity, volatility, flammability, phase, and solubility looks like. But for now, let's have our activity for module number 5. In module 5, activity 5, you can see a comics there. So all you have to do is to read these comics carefully and then answer the guide questions that follow. Okay? So that's how you are going to answer activity 1. In module 5, activity 2, there is a table of organic compound there. So all you have to do is to put a check on the correct uses of each compound. For example, LPG, liquefied petroleum gas. What is the use of LPG? Is that antiseptic, beverage, cleaner, disinfectant, food, or fuel? I already discussed what are the differences among the antiseptic, lubricant, disinfectant, fuel, and then I also gave some examples of organic compound. So liquefied petroleum gas. What is the use of LPG? That is to fuel our tank for us to cook some food. Okay? How about the kerosene? That is also fuel. Acetic acid or vinegar is used as a cleaning agent or cleaner and can also be used in cooking. So food, you have to check the food. Formaldehyde or formalin, it is used to treat human cadavers or dead bodies for disinfect the bacteria and viruses. Okay? So disinfectant is the use of formalin or formaldehyde. So this is the way you're gonna answer your activity 2 module number 5. And in module 5 activity 3, it's all about experiment on the properties of organic compound. And for you to answer the questions on activity 5, please be guided on the following videos that I will show you now. It regards with how you are going to know if it is organic, if the organic compound is flammable, volatile, viscous, and soluble. So in the following videos, you can be able to determine the phase and odor of the compound. So you have to take a closer look and concentrate on watching. Okay? So let's begin. I hope the previous videos will help you to understand better the properties of organic compound. Once again, let us have a recap of what are the properties of organic compound that we have talked about a while ago and also on the videos that I have presented to you. So odor is the smell, if it is strong or weak. Viscosity, if it is viscous or more viscous or not viscous. Volatility, easy to evaporate, meaning more volatile. Not easy to evaporate or it takes so many hours before it evaporates, that meaning the liquid or the organic compound is not volatile. Flammable, when the compound can easily burn, that is flammable, like the gasoline. Phase is that a solid, liquid, or gas. Soluble, soluble or insoluble. It can mix to other, like uh, sugar and water. They can mix soluble. Salt and water, they can mix. They can mix as one, so they are soluble. Water and oil cannot be mixed, so they are called insoluble. You cannot mix water and sand, right? So that's insoluble. You cannot mix water and marbles. So that's insoluble again because they are separated into two. So those are the properties of organic compounds and uses. They are very important in our everyday living. So this module, I hope it will become a help for you to appreciate more the organic compounds that surrounding us because they are very helpful in our daily lives, most especially to the adult one. Okay? So with that, I hope you learned something today, and before we end up, here are your assignment of the week. Please upload your answers on Google Classroom on time. First in line, we have Module 4. Next is Module 5, followed by Quiz 4 on Google Form, and then Performance Task number 3. So, Module 4, 5, and Performance 3 should be uploaded on Google Classroom by the date that I will assign to you. And Quiz 4, as always, you have to answer it on Google Form. Okay?